afternoon and welcome everybody to today's Data Management Specialist Group webinar. Today's subject is a talk on how time flies, navigating temporal turbulence in enterprise data. To help us with this navigation, I'm joined by my colleagues here, and I'd like to ask them to introduce themselves. Jagdev.
Good afternoon. My name's Jagdev Bogle. I'm Associate Professor in Computer Science at Birmingham City University and Course Director for MSc Big Data Analytics. Thank you all for joining.
Thank you, Jagdev. And Luke?
Afternoon, everybody. I'm Luke Porter. I'm the CEO of LD8A Limited. I've had some 30 plus years in the IT business. LD8A Limited is a startup company that has been brought about because of the potential of the savings and capabilities of harnessing the relationship between time and data.
Thank you, Luke. And Rob?
Hello, everyone. My name is Rob Squire. I'm the CTO of LD8A. I've been an Oracle full stack developer since the early 80s and continue to do that.
Thank you, Rob. So it's always good to see such engagement with our BCS data events. We hold a series of these events throughout the year with the aim of providing insight and expertise to our membership so that they can build up their knowledge and develop their network. So yeah, please feel free to reach out to us on LinkedIn or visit our website, the BCS DMSG website, where you'll find a recording of this talk when it gets published there, and also a lot of our previous talks, which, from experts around the world on many of the different topics in data. They provide a fascinating series of information there. So let's get started. We'll hear from Rob, and please feel free to post questions in the Q&A. I hope you enjoy this session.
And I'll describe the features and functions of an approach used by LD8A and how that applies to the case study, which should leave us about 30 minutes for Q&A. I'd like to start with a quote from Professor Richard Snodgrass in a book he wrote entitled Developing Time-Oriented Database Applications in SQL. He's eminent in the field, and he said, looking back on the history of the development process, everyone has a vague idea that the problem started when that pesky date column was added. How can one column flummox the whole system? Why do some columns, such as the birth date column, slide in smoothly? Other date columns cause no end of problems. And we agree with Professor Snodgrass. Dates are very disruptive and cause complexities in the data that, as developers, we need to deal with. So this is typically how it goes when designing a schema. At some point, we decide that one of the tables needs a date column, recording when the row was valid, the from date. And so we rework that part of the application which updates that table. And we notice that the code is getting a little bit more complicated because of that. And during the testing, we discover that the primary key is no longer sufficient. So we add a from date to the primary key, acknowledging that this is only a stopgap measure in the hope that the data being input will be well formed, since there isn't time to write the code that checks the constraints properly. And in the back of our mind, a doubt forms that maybe the referential integrity checking won't now work correctly. And we soon realize that we need another date to record when the row was no longer valid, the to date. And in doing so, we encounter a raft of out by 1 day bugs. And we know for a fact now that the primary and foreign keys are wrong. It's hard, even pointless, to join to a table that has a primary key with dates in it. And the code to modify the database is becoming increasingly convoluted. Each DML update has to at least consider changing the date column, but it isn't at all clear how to approach such changes in a systematic fashion. And even the most trivial queries, such as who was Aaron's manager when he worked on the capital account, have now become painful to code. But we don't even know how to approach that mess. And the users are now complaining that their reports aren't consistent, that copies of the end of year summary have different numbers in them. And when looking into the problem, we noticed that the reports were run at different times and data had been changed in the meantime. And we realized that there's no way to correlate the end of year report with the cash flow report unless they're run at the same time. And to address these inconsistencies, someone suggests a quick fix. Let's add another date column. And the developers respond with astonishment. How can we possibly get the code working with yet another date column when we all know how much work resulted from adding the previous date columns? Whoops. And over the years, as developers, I'm sure you've all experienced something like this. And we've all had to work out various coping mechanisms. It probably meant creating a history table or an audit table, maybe an intersection here and there, and complicated subqueries in the where clause. And maybe it just got too hard and either it was descoped or left up to the application layer to deal with. We all know that databases can store dates and even do data arithmetic, but we've accepted the fact that relational databases don't intrinsically understand the semantics of these date columns. So we just get on with it and cope with the best way we can. And I'm sure that's no surprise to you. Adding those pesky dates seemed like such a trivial, obvious thing to do. And what choice did you have? The business needed them. But dates are like wolves in sheep's clothing, and adding them to the schema introduces significant complexities that as developers we need to cope with. And you already do, because without a supporting framework, all that turbulence has to be dealt with case by case by the developer. And so we come to a pivotal moment in this presentation. And I need to ask the question, why would you consider using a framework when you already have coping mechanisms that work for you? Are the benefits of a framework significant enough to overcome the inertia of 30 years of coping? Well, Gartner thinks so. Yes. And as a general principle, as a general principle, frameworks are a good thing. Once a pattern is identified and a framework or a function can be created. Some of you maybe remember a time when aggregates and data arithmetic were coded by the developer, and nowadays databases provide functions for that. However, a framework to deal with the dates in a systematic, automated way has always been very elusive. And because dates are so pervasive in our schemas and developers have been coping for so long, the benefits of moving to a framework instead of continuing with our existing coping mechanisms have to be very strong to overcome that natural inertia. So here are two major benefits of using this particular framework. Firstly, if we deal with dates in a systematic way, an automated way with a framework, then the complexity is removed from the developer and the applications are easier to code and maintain. And if that isn't enough, then the next benefit brings us right up to date and ready to take advantage of the next evolution in data management. When your data is well formed with respect to dates and times, it puts you in an excellent position to take advantage of artificial intelligence. AI models fed by time series are all about how to gain deep insights from our data. And in 2024, this is the state of the art in AI. We see the emergence of something called retrieval augmented generation, or RAG, and contextual intelligence platforms. RAGs are basically enterprise large language models that have been trained with relevant proprietary enterprise data sources, rather than the generic public information used by ChatGPT. And here's an example of an AI architecture designed for the decentralized finance world of cryptocurrencies. Large language models are used as the mouthpiece to insert prompts. The information is then collected across a massive range of data sources, the internet, proprietary data, information about blockchain on various blogs and articles. And the information is synthesized to generate those insights using things like investment scores, risk profiling, and so on, so that we see, so that we can prompt the AI with questions like, hey, people, when people feel good about Solana again, please buy some. Our technology, or this framework, which we've called the autonomous ledger, fits very nicely into this AI platform as just another data source which offers high quality complex data as a time series. It can also be used to store metadata from the other data sources if required. What we're talking about here is an approach that applies to all systems of record in all verticals, whether it's healthcare, manufacturing, asset management, so on. They all store data, and they use data which is typically held in a database. And over the decades, databases have grown in their capabilities. As the database infrastructure offered more services to the developer, there was a commensurate reduction in the costs and the complexity of the projects. And in the early days, databases did little more than select, insert, update, and delete and commit. By the 80s, row-level locking was common, data arithmetic, of course, multi-version read consistency. This is by no means an exhaustive list, it's just ones that I've picked out. By 2000, we saw analytic functions, and the databases knew about referential integrity and enforced it. And right now, bringing it up to date, databases cover things like blockchain, cryptography, machine learning, AI. All these things have been subsumed into the data architecture. And we all know that relational databases can store dates, and they can do data arithmetic. That is to say, they understand the syntax of those dates, but they don't understand the semantics of those dates. And this is because Ted Codd's relational theory specifically excluded time. And traditionally, developers have had to implement complex logic and write custom code to deal with those effective dates in the data. And this is not only time consuming and error prone, but also adds complexity to the application code base, making the maintenance and future enhancements challenging. By offloading the responsibility onto the database itself, developers can focus on building the core application functionality and delivering business value rather than getting bogged down in the low-level data management tasks. Also, by dealing with the dates in a systematic way, it enables easy access to data as a time series. Answering complex audit and compliance questions becomes straightforward when time is treated as a first-class citizen in the database. So, I'd like to now explore the concept further by using a case study from the financial world of futures currency trading. So, banking regulations require that banks create an end-of-day trading report reflecting the bank's position at the daily close of trade for every customer and for every position that those customers might be sitting in within the bank. And the report shows trades and balances, potential gains and losses as of the close of play against positions. You'll notice that the value date is the thing that groups trades together, in this case the 9th of September, and every trade that has the same value date gets put into the same position. Any system of record, of course, needs to accommodate updates and corrections, and futures currency trading is the same. We have to incorporate late trades, security exchange rate corrections, updates to trades, removal of rogue trades, and a host of other corrections that occur after the report has been sent out to the customer, requiring a second report to be sent to them. The system needs to cope with all of this. And I'm sure as experienced data models among you, based on that requirement and given enough time, you would come up with a schema such as this: a table that holds clients, the securities that have been traded, the trades, and the grouping of those trades into an entity called positions, defined by the value date of the trade. So just to illustrate how that schema would be populated, imagine a timeline. The position is created. It has a start time, a from date. That is the trade date of the first trade. It has an end date or a to date, the value date of the first trade. And then the trades are entered into that position. The first trade defines the start and end date of the position. The first trade goes into the position. More trades with the same value date are put into the same position. So you can imagine now trade 2 goes in, that's the trade date of trade 2 with the same value date, referential integrity being maintained in time so that the trades inherit the end date of the position that they're placed into, taking the effort away from the developer. The infrastructure does that for you. The third trade goes in with the trader date of that into the same position because it has the same value date. And now once the data is in there, we can run the end of day trade report at any time that we want to run that report at. And the system needs to be able to pick that time out and run the version of the report as required. Each query produces that end of day report at a required point in time. So time is all over this requirement, but the developer doesn't need to worry about it because the framework is dealing with it. So what would a systematic automated approach to this problem look like? Rather than a developer coping with all that complexity, how would a framework deal with that complexity? Well, the first thing to say is we're not just talking about one schema here. We're talking about any schema that you want to design, any vertical. So it could be a complicated schema like this for supported housing. It could be a schema for nuclear fuel reprocessing. But we're talking about futures currency trading here, the client's position, securities and trades. So we take the schema that's been designed, in this case, the 4 tables that we just discussed, and we take that as an input into a code generator. And this code generator creates a set of artifacts that something that allows you to set the context of time, which is very important. All the time series and ways of looking at the data across time are generated by the generator automatically. The coder doesn't need to do that. All the rules for what happens when you update and correct data, what effects does that, what ripple effect does that have in future dates, future data that's logically in the future, and all the temporal logic usually written by coders to make sure that as the data is inserted, updated and deleted into those tables, that the referential integrity is maintained over time. All that is generated, as well as the ability to query across histories. All come from the generated artifacts. And we've called those artifacts an autonomous ledger. Remember, it's just a database with a generated data structure and a code base that understands time, but it's been generated for you. It treats time separately from the data. Time has finally become a first-class citizen in this structure. Once generated, the ledger acts as like a traditional transactional database for your applications. It means that the applications can be built rapidly because the developers can rely on the ledger for all the temporal aspects of the solution. And complex time series can be projected from that ledger and used to feed the AI models for those deep insights based on the patterns and correlations in the data. So now that we've got our generated autonomous ledger, how is it used in the case study? Well, when we look at the end of day report, we see that dates are intrinsically linked to that requirement, the value date, the trade date, the reported date, and so on. But now the developer does not need to worry about the turbulence caused by those pesky dates. They just model the current view based on the business requirement, in this case, client securities, trades, and positions. And the ledger takes care of the storage of that data, the history. It projects from that stored history the current view and the time series for all the event histories that are for the corrections, and the time series for all the entity life histories, all generated by the ledger for the developer to make use of in the application. So we have a physical generated layer and a logical set of views that are projected out of that physical layer. Which gives us a comprehensive, accurate time series, which we can use to train our enterprise large language models, and on which we build our applications, of course. So that end of day trading report is really just a simple query, a relational current view query joined by business key without any complicated where clauses for time. It's just a simple query that can be plugged into several very useful time series. And notice that the time is separated or factored away from that relational join. We're joining by the business key. And this is the key to simplifying the turbulence caused by those pesky dates, the separation or the factoring away of time from the data. That's how we achieve it. So the first of these time series that I've alluded to, we call the event history by calendar. And it's basically, think of it like this. It's not just a time series of simple results like an aggregated sales figure for a region. It's any complex report or query on the data, which is then plugged into that time series. So in this example, the end of day trading report is plugged into each point in the time series. So for an event history by calendar, we pick the dates that we want to sample in the calendar. In this case, the first of the month. It could be by quarter or year, it doesn't matter. It's whatever you decide. And the autonomous ledger projects back to you the event history of all the corrections that have happened on the date that you choose. And you can project that time series out at any calendar date that you wish. At each point in the time series is a complex result, i.e. the end of day trading report. This becomes very helpful for AIs to spot models, spot correlations and clusters of changes, for example. The second time series that we project is the event history by entity life history. So it's the same idea, the same report, but in this time we're driving it by dates within the data, important dates that are within the data, like, for example, the value date, or the date of trade number 3, or the date of trade number 2, and so on. So the same projection, but picked on dates within the data. The third kind of time series we call a calendar history. So same idea, complex report, but this time we cut horizontally through the entity life history. So we now see how that report has evolved over business time. We sample it at our chosen calendar dates, but we now see a time when there was only 1 trade or 2 trades or 3 trades and so on. And we can peel back the corrections and show the same entity life history, the way that report has evolved over business time, and peel back the corrections. Again, very useful for finding patterns and correlations. And the final one is an entity life history, but this time picking out important dates within the data itself. So the same idea of the entity life history, but specifically at points within the data, peeling back the corrections that happened on that data. And once the AI has used those time series and identified those patterns of interest in the data, then it can focus on specific points of interest in the current view projection. So the report that we're talking about, or any other query that you might want to use, can then be targeted at specific points in this two-dimensional map of transaction and valid time. And you can navigate around that two-dimensional map and look and pick out specific points of interest to give you further clarity on what's going on in the data. From a performance perspective, the ledger, that schema was loaded with a typical workload of 22.5 million trades, over 100,000 positions, 1,000 clients, 100 securities, and we timed how long it took to put data in and pull data out in those time series. And as you can see from the chart, this was done in sub-second times. It was done on a Windows PC. Typically, that amount of trades done in a month in a large merchant bank would be done on a large data warehouse, which would take a long time to populate and wouldn't have the granularity that this transactional approach has. It's not just a theory. This underpins all the applications built by LD8A. For example, we have a CloudDig SaaS application for supported housing. It took 2 developers 6 months to build from scratch using this framework. Without the framework, the team would have been much larger and would have taken much longer to build. And the delivery was rapid because data effectivity had been factored away from the developer during that development. So in conclusion, an autonomous ledger represents, we believe, a game changer in the realm of data management. By autonomously maintaining the referential integrity of data across time, the database eliminates the need for developers to write complex code to enforce those data relationships, leading to a streamlined development process, an improved data quality, and an enhanced operational efficiency. And by providing accurate, easy to access time series data, we find ourselves in an excellent position where we can train those enterprise LLMs for the latest RAG artificial intelligence platforms. So we put ourselves into an excellent position for that. So I started this presentation with a quote from Professor Snodgrass, and I'd like to finish with this one from Ben Michael Schuler in a paper entitled Update Reconsidered. He'd already recognized even then that the turbulence caused by when dates are allowed to be updated. Unfortunately, due to the cost of disk storage at the time, the idea of an insert-only ledger approach was impractical, and so database infrastructures were built to allow updates and deletes, and as they say, the rest is history. He said, the database is not the database, the log is the database, and the database is just an optimized access path to the most recent version of the log. And we would say it's actually an optimized access path to any version of the log. Thanks for your attention. That's the end of the presentation, and I'd now like to hand over to Ed for Q&A.
Yeah, thanks very much, Rob. That's a detailed explanation, and I love the graphics there to help us through that. Just before we go to Q&A, Jagdev, what's your kind of position in the university on what we just heard here?
Okay, so I'm module lead for the Advanced Databases course module, and we encourage students to learn about the different additional types of data models that are in existence. And so we encourage guest talks from industry. So a couple of years ago, Rob and Luke came to do a guest talk to our cohort. In my experience, especially with data modeling, I think that students sometimes find it confusing when they're building relationships between entities, whether to model them as current data or historical views. So sometimes that can be quite confusing. So after the students saw the talk by LD8A, they realised that by using an architecture like this, where the autonomous ledger handles all the historical data, the data models become much more simplified because you're only modelling the current view. And as a result, also data-based queries become more simplified. So the students were really interested in this, and we also encourage industry mentored projects. So Luke and Rob were happy to kind of mentor our students who wanted to use this architecture for their projects. We had 7 master's projects making use of this architecture, of which one was actually accepted at a conference in Italy. So making good progress, and moving forward, we're now recruiting a PhD student to take this work further forward, especially in terms of applying AI analytics on the time series data and so on. So I think the students and myself are really excited about these new architectures out there in industry. But the core material is relational, but we do need to make students aware of other architectures that exist as well.
And may I add there, Jagdev, that one of the projects a student chose was the car ownership scenario used by the AWS QLDB product. And they effectively did a sort of compare and contrast assessment. And what was brought out of that is, whilst QLDB is insert only and cryptographically locks the data, it doesn't do the key thing of capturing the semantics or the time semantics of the data as it's entered. So what was brought out there was that when those sort of questions, who owned what, when, and how that changed, the only way that it could be addressed from a QLDB point of view is to go right back to the start of the log and work through identifying any transactions that were related to that query, obviously very time consuming, to build up the response to the query. From our point of view, because the framework is laying that data down in a very time-friendly pattern, the crosshair is just set for the point in time that the query needed to be targeted at, and the data was returned. So this will sort of touch on some of the more technical aspects. The key thing in being able to identify data is not so much the volume data that you're having to look at, but it's the number of records that you have to touch or skewer for the query that you want to bring back. And that's the number. What we're doing. This framework approach ensures, as the data is time friendly, it's only bringing back those records that are applicable to the report, and all done autonomously without any specific coding. Sorry about that, Jagdev, but that student project was a very useful one. And whilst they had no appreciation of the pain that what normal development would entail, it did enable them to do that sort of comparison.
Absolutely agree. Yeah, thank you.
Yeah, thanks, Luke. I'm going to come to Luke again in a minute to ask about the how the technology relates or impacts with some of the big database companies out there, and what their opinions are. We've got a couple of questions on the chat. I don't know if you can see those, Rob, but there's a couple of questions from Kathy. One is about it's a pretty detailed question about any reason you chose to use the pre-1992 syntax for joins in the example. Select code rather than the most recent join syntax. Is that?
Well, yeah, well spotted. It's because we've been this query was taken from a presentation that was written when Oracle didn't have, typically we didn't use that syntax. So, but as far as we're concerned, we're just code in the Oracle database. So any syntax, any features of the Oracle database are all, we're completely agnostic to all of those. So we don't require any particular way to write queries. It's just a normal it's just a normal query on a normal database. So if you want to use left outer join or that syntax, then that's no problem at all. It's just at the time of writing that particular query, I didn't do that.
Well, it was well spotted. Nothing escapes.
No, that was really quite impressive.
A second question from Kathy is about would the SQL standard benefit from the inclusion of crosshair in the select clause?
Well, when I was at Oracle, I was invited onto the committee that discussed that very point with IBM and Oracle. And I put my point of view forward there. That was maybe some 10 years ago. And they went down a different route, unfortunately, for me. So they do, there is a T-SQL element to the standards now. And the syntax of trying to deal with dates and times is part of that. We don't use that syntax. We just use the standard syntax of SQL. We don't use any bells and whistles. And we believe that changing the syntax of the language is only really the top layer. What you really have to work out is how to hold the data, the structure that the data is held in. Having the syntax there is all well and good, but the data has to be laid down correctly, precisely, with referential integrity, and so we believe that we've taken that approach. We've concentrated on how the data is laid down, what those history tables look like, how are they indexed, and we've used the syntax of the standard syntax of the language. And you'll probably have noticed that we've separated the temporal context setting outside the query. So this is a key thing. We tell the session what the time is, what the time context is, and then so we're effectively setting what now is, what the current view now is, and then as you're querying in the session, you're just working in the current view. So we don't need the syntax of time in the query. We just need to tell the session what the time is, and then just do normal, straightforward, standard SQL for our queries because we're in the current view.
Yeah, thank you. And there's another question from Nick. How does the autonomous ledger cope with the changes in the database schema over time?
Just like any other schema, you would regenerate. So if you didn't have an autonomous ledger and your schema changed, you would have a migration process to move the data that's in your current schema to the new schema. So we're no different in that respect. And any query, we realize though that in transaction time, the boundary of when the schema changes, there's no real use case for having a query that crosses that boundary. So it doesn't make sense to have a query that looks at some data where a table had a column in it which was populated, and it doesn't make sense to have a query that spans that change in schema to another version of the row that didn't have that column in it. So it's just think of it like a traditional database. If you change your schema and a traditional database, you would have a migration to the new schema where you would populate any mandatory fields that in the new schema, where you would remove the tables that need removing. And then from then on, all the queries work on that version of the schema. So it's no different to any other database that you already work with in that respect.
We've got another question for Rob, but before we do that, give Rob a bit of a rest, Luke. It's fascinating to see how the technology integrates with the big database organizations, and how you're kind of adding value to the implementation by providing additional functionality. And what's the kind of relationship like between what do Oracle regard? How did Oracle regard this technology and big organizations like that? Are they starting to look at it seriously?
It's a difficult one. On a positive note, in recent years, Oracle, for example, have made a lot of use of the autonomous term, which is effectively automating those processes that would otherwise been carried out by system admin or, as Rob alluded to in the presentation, aspects of normal development. But the temporal aspect in regard to relational, because it's got this fundamental issue, which is essentially retaining the integrity of the COD's approach to the relational data. It's a very fundamental thing for the large players such as Oracle to look to how to accommodate this. There are ways, in the sense, and Rob is probably better at it, but this could be implemented in a table space, for example, within Oracle, or more fundamentally into the kernel of the software. But this is a key thing it's nearly a strategic architectural decision, because the history of computing in database architecture is that when it came from a point where processor, disk, memory was expensive and not performant enough. Now we're into a world where all of that is nearly immaterial in terms of what you want to deliver. So if we were to actually start designing an architecture, database architecture now, we'd probably start from the point where, well, we'll just make it append only, but and insert only. But of course, insert only has to accommodate what happens in the real world. And the real world is about corrections, updates, all those things that happen in a normal enterprise environment. But it has to be captured that way, because for compliance, audit, just the way things are. So in answer to your question, on the positive side, there is a view to looking to bring in or addressing the autonomous aspects, and the temporal dimension is a key one for to be addressed in the but it has to be addressed at a deep architectural level. I would say the key point here is that there's a difference between just delivering a syntax and the semantics. Syntax is easy. That's a superficial layer of just, and no different to AI, posing a question. Posing a question is one thing, but understanding the semantics, i.e. capturing the logic of what it, in this case, the data logic in the context of time, is quite a tricky one. And it's, architecturally, a significant change for the present development.
Very good, thank you. I've got another question for Rob from Graham, and then I'll invite anybody on the panel here to sum up. So there's a question: does this framework approach mean that you have to develop the models in a new application, or can the framework be back engineered into an existing application?
That's a great question. Glad you asked it. So if you've got an existing schema that's already coped with the dates, it'll have histories, audits, dates physically in the schema, then it's too late for those sorts of applications. However, if you could imagine every event that happens in that application, if those events are trickle fed to the autonomous ledger on the side, so a little bit of development required, but identify the inserts, updates and deletes that happen chronologically. Every time they happen, feed the autonomous ledger with a trickle feed. You then have the autonomous ledger on the side, which would be an excellent resource for reporting from. It would also it would act like a policeman on the events that happen in your application. If your application made a temporal error that wasn't noticed by the application because the code had been written by a developer and that part was missed, for example, you're putting a room into a property that doesn't exist yet, or a resident into a room that doesn't exist yet, something like that, then as you trickle fed it to the autonomous ledger on the side, the autonomous ledger would notice the temporal problem and report back as an error to the main system, and either stop it from doing that mistake or just report that something's gone wrong. So there is a room for autonomous ledgers to sit alongside existing applications. But to answer your specific question, once the schema's designed, the application's inherently tied to that schema, and it's kind of too late. Apart from a re-engineering of the entire application, it'd be too late for existing ones. The best you could do is trickle feed on the side.
Thank you. Thank you. Well, we've had some great questions. Just want to ask the panelists here if there's anything they'd like to close with. What would you like people to take away from the presentation we've got now? We just had there. So, Jagdev, anything you'd like to say?
Well, I mean, we're really excited about this architecture and see where it can take us in terms of the AI analysis of all this rich temporal data. I'm really excited about the prospects about this and looking forward to the new insights that we can produce. Yeah, and it'd be great to see some of the from your research being presented here in the future too. So results from all that. Luke, anything to summarise and add?
We're very happy to have any sort of engagement in terms of proof of concept. The beauty of our approach is the fact that it's current view. If there's something an enterprise would just like to try out in terms of their own enterprise data, then please contact us, because as I say, because it's a framework, it's fully developed, it's fully there. It would be a straightforward exercise for us to look at a proof of concept.
A matter of generating more use cases and adding to the richness of the case history there, yeah. And thanks, Rob. What a great presentation. Anything that you didn't say that you wanted to say?
Only that don't forget, it's just a database with code in. There's nothing different about this than that you would normally have to code yourself. So don't be afraid of it. Also, quite excited about looking forward with the potential that it has for AI and RAG. We've been looking back at existing applications and building applications, but I think as we pivot towards looking into the future and how we can be a data source for AI, find that very exciting.
Right, brilliant. Listen, thanks very much for everyone attending that. Like I said, the recording will be presented via the BCS website on the DMSG, BCS DMSG, if you find that there. I'm going to ask Jagdev, Luke and Robbie to stay on, because I think we need to record the introduction again, because I didn't press the recording button at the right time. But so if you just stay on, and we'll just go through all that again. But thanks very much, everyone, and see you at the next event.
Thanks, Ed.
Bye all. See you later.
Bye.
Thank you. I'm just going to literally record exactly what we said right at the start, and then that can go into the edit at the start of the recording. Good afternoon and welcome to today's BCS Data Management Specialist Group webinar. Today's talk is titled How Time Flies, Navigating Temporal Turbulence in Enterprise Data. To help us with this navigation, I'll ask my colleagues here to introduce themselves. So please, Jagdev.
Hi, good afternoon, everyone. My name is Jagdev Bogle. I'm Associate Professor in Computer Science at Birmingham City University. I'm also Course Director for the MSc Big Data Analytics course. Thank you for joining.
Thank you. And Luke?
Afternoon, everybody. Luke Porter. I'm the CEO of LD8A Limited. I've had 30 plus years in the IT industry. LD8A Limited is a startup company for a concept that we've been looking at for a number of years, which is the power in harnessing the time dimension in relation to data. I hope you enjoy the presentation today.
Thank you, Luke. And Rob?
Hello, everyone. My name is Rob Squire. I'm the CTO of LD8A. I'm an Oracle full stack developer started my career in the early 80s and have been doing that since then. Thank you.
Thank you very much. It's great to see the engagement from the for our BCS data events. We hold a series of these throughout the year with the aim of providing insight and expertise for our members so they can build their knowledge and extend their framework. So please feel free to join us on LinkedIn if we're not already linked in, and sort of spread your network in that way. We also have a website page where you'll find information about this event and the recording of this event and a lot of our previous events as well, which has got a fascinating history of experts from around the world on all the different aspects of data, which is becoming a much wider and wider topic.